It says identify the solutions that would make an effective buffer. So we have NaCN and HCN. So basically, in order to have an effective buffer, what we're going to want to have is a weak acid and its conjugate base, or we want to have a weak base and its conjugate acid. So if we look here at NaCN and HCN, NaCN is essentially Cn minus, right? Na is just the counter ion, Na plus and Cn minus. So we have Cn minus and HCN. HCN is a weak acid, Cn minus is its conjugate base. So this is an effective buffer solution. Hi and Ki. So Hi is an acid, and Ki is its conjugate base. Remember, this is just K plus, 1A metal plus, and it's I minus. So you have Hi and I minus. The problem with this one is that this is a strong acid and not a weak acid. So since this is a strong acid in its conjugate base, it is not an effective buffer solution. Here we have acetic acid, HC2H3O2. This is acetic acid, a weak acid, and NaC2H3O2, sodium acetate. So we have a weak acid and its conjugate base. This one will make an effective buffer. In this case, we have a weak base. This is methylamine, made famous in the show Breaking Bad. That should be an NH3. So this should be a 3 here. So it should be, what am I doing? No, it shouldn't. It should be a 2. Sorry, CH3NH2, methylamine. And then we have CH3NH3Br. So this gained an H, making this a positive charge, and Br minus is just the counter ion. Sorry about that. The 3 should be here, not here. So it's CH3NH2 and CH3NH3Br. This is a weak base and its conjugate acid, because it gained a proton. All right. Therefore, this is an effective buffer solution. H2SO4 and NaHSO4. This is an acid and its conjugate base, HSO4 minus, but sulfuric acid is a strong acid, so this is not an effective buffer. NaF and water. NaF is a source of fluoride you might find in toothpaste. Okay, and water. This is not a conjugate acid-base pair. So NaF and HF might be a good buffer, although it might have other problems. NaF and water is not an effective buffer because we don't have the weak acid and its conjugate base. So this is how you identify it. Again, effective buffers are a weak acid and its conjugate base, or a weak base and its conjugate acid. Don't get thrown off by the 1A metals. That just means that you have this minus. And in the case of a weak base, here you have an H, which makes this thing positive, and then the counter ion is often a halide because that's going to be 1 minus.